Hey guys, Fitness Science, and today I'm going to explain how you lose weight from a cellular level. There's a lot on YouTube about how to lose weight from like a just general point of view in terms of implications and tips in your everyday life. But I actually want to take away the mystery of what's going on at a cellular level in part 1 of this series. And then part 2, I'm going to explain how you take those findings and incorporate it into your everyday life. Basically, we store fat from the food that we eat, and our fats are ingested in our diet and they travel into our small intestine, and then they travel from there, they're broken down and put into our fat cells themselves, which is called adipose tissue. And the body has an unlimited ability to store this fat. See, from carbohydrates, we actually have a limited ability to store carbohydrates in our body. So that's not going to be very useful if we go through periods of starvation. Now, the body adapted from when we had scarce food sources. It needed a way to be able to store high amounts of energy on our frame to then call upon if we didn't have the food available to us. And fats were the perfect mechanism for this. Fats can easily be stored in adipose cells, like I said. And for our body in times of starvation, it was a really quick way for our body to be able to call upon energy to keep us alive when we didn't have food for days or weeks on end. But the question for a modern day human who has abundant food almost 24/7 on call is, how do we get rid of this fat when eating feels so good and we love our food because it's delicious and it tastes good?
Hot food.
We want to be able to actually get rid of this fat. We know quite clearly that a caloric restriction will lead to a decrease in fat, but I wanted to explore today the cellular processes with you in order for you to better understand what's going on at a cellular level, and it might actually help you make some changes in your diet to better mimic what's going on at a cellular level. Weight loss has always seemed to be a bit of a mystery, or it's not very well understood or explained from a cellular point of view, so I'm going to break that down right now. The process is called lipolysis, and that essentially means the breaking down of fat. When the body needs it, our fats can actually be broken down into a free fatty acid and a glycerol backbone. Just for some background before we start, the free fatty acids that are liberated from our adipose tissue are actually released into our blood and are taken up by most living cells in our body that can then use it for ATP, which is our main form of energy in the body, to fuel our metabolic processes. This all takes place in the cytoplasm of the cell, where the fatty acid is turned into something called fatty acylcarnitine and transported through the inner membrane of the mitochondria into the mitochondrial matrix through something called the carnitine acylcarnitine translocase, which is an enzyme which essentially shuttles fatty acids through the mitochondrial membrane and into the matrix of the mitochondria in order to actually be used for energy production. From here, the fatty acylcarnitine is converted into fatty acyl-CoA and then into something called acetyl-CoA. This is a key molecule in the body and is involved in the citric acid cycle, which is basically another way that our body creates energy. This newly created acetyl-CoA that was made from our free fatty acid can now feed into this cycle in order to help our body create ATP and fuel our cellular processes. Okay, so bear with me, I know that was really complicated, but basically all you need to know is that our body has the ability to take a free fatty acid from the fat tissue that we have that has come from our diet and use that free fatty acid to feed into a cycle of creating ATP to fuel our body's processes. Everything from our heart beating to our muscles moving to digestion can be fueled by our fat. But going back to the beginning, I want to actually explain to you the exact process of how our body breaks down the fats, but also the signaling that goes on. When we lose weight, we want to essentially signal to the body that we want to break down fats. I want to explain to you exactly how that's done and what the signaling is for that process. So let's get into it right now. See, most people have a huge amount of fat on their body that can be called upon and is a huge component of our extra fuel sources that we can call upon if we need it. But basically, we need some way of breaking down the fats in the first place, then getting the fats into the blood, and then getting the fat from the blood into the cells that need them to fuel ATP synthesis. And guess what the most powerful stimulus is? It's called fasting. Remember how I said that the fat has to be broken down into a glycerol backbone and a free fatty acid for all of this to occur? Well, one of the only enzymes to do that is something called hormone-sensitive lipase. So basically, fats are stored in the adipose tissue as triglycerides, and hormone-sensitive lipase is an enzyme which has the ability to break up this triglyceride into a free fatty acid and a glycerol backbone. But the question is, how do we actually activate HSL in the first place in order to start ripping apart our fat cells to be used as energy? This is something we all want. We want our fat cells to be ripped apart and taken away, and therefore we'll be left with the rippling six-pack abs. But how do we actually turn on this hormone-sensitive lipase? Well, it's actually regulated by a lot of hormones. Two of the most important are insulin and adrenaline. Insulin deactivates it, actually turns it off, and adrenaline turns it on. It activates it to start breaking down fat. Norepinephrine is very similar to adrenaline, and norepinephrine is released when we're fasting. This norepinephrine moves to the adipose tissues and it binds to the beta-adrenergic receptors on the actual membrane of the lipid cell itself. And through a cascade of biochemical pathways, that HSL gets turned on and it allows the HSL to start working on the fat cells and start ripping them apart, the triglycerides, and getting the free fatty acid out into the blood. And basically the exact opposite happens when we eat. So insulin spikes when we eat, and insulin has a huge anti-lipolytic effect, which is anti-fat breakdown effect in the cell. Insulin turns HSL off, but it also tells a little thing called a glucose transporter to bring glucose into the cell and through a series of chemical pathways turn a fatty acid into a triglyceride for storage. So insulin both turns off the ability for the cell to break down fat, but it actually stimulates fat production by getting glucose into the cell. That becomes the backbone, and then free fatty acids that come in can then bind to that and create a triglyceride. So basically, norepinephrine stimulates HSL to break down fat, and insulin tells it to stop breaking down fat and actually creates new fat in the presence of fatty acids. So the fatty acids actually already have to be there, but if they're there and you have had a huge insulin spike, the glycerol backbone will be produced and you will get the formation of new triglycerides, which is essentially the formation of new fat in your body. So basically, to lose weight, this HSL has to be turned on, and one of the most potent stimulators to turn it on is fasting, as a result of the norepinephrine moving to the membrane of the fat cell and being able to basically turn on HSL and therefore break down the fat. When we're fasting, the body is actually in a state of stress, and that's why these hormones are produced. And then the hormones move to the actual membrane of the fat cell itself and has all these wonderful effects, such as breaking down fat. The fat is then moved into the blood, like I said, and once in the blood, it then can move to the cells that actually need it to be used in a series of chemical reactions called the citric acid cycle, to then be used to create ATP. To lose weight, the tough reality is that for some period of the day, you need to be in a caloric restriction. You need to essentially be in a mini fast or a total fast in order to get these hormones produced to be able to then move to the fat cell and tell the cell to break down fat. But the tough reality is that we love our food and our food tastes good and we love eating. And the modern society doesn't really want to be in a fasted state because food tastes so good. And why would a modern human want to be in a fasted state when we have things like donuts and chocolate and sweets and lollies and all this wonderful food that we can eat and we can enjoy? Well, the truth is that for some period of the day, we're going to have to accept reality and accept the biology that in order to burn fat, HSL has to be turned on. And one of the most potent ways to turn this on is through fasting, as a result of the hormones that are produced from fasting. Restricting your calories is a way of doing this. And in part 2 of this video, I'm going to take this biology and put it into practical implications for you to take away and actually implement in your everyday life. Thank you for watching the biology part. This is part 1. Please consider watching part 2, where I actually explain the implications of just how you do this in your everyday life. This channel is about educating you as much as possible in order to get you to the point where you can smash your goals confidently with the backing of science and research. Thank you for watching, and I'll see you in part 2.